The second type of projectile motion starts on the ground and ends at the same height. If an object is launched at an angle with the horizontal, the analysis is similar except that the initial velocity has a vertical component. Projectile motion can be described by two kinematics equations. X equals x naught plus v naught xt plus 1/2 at squared. X naught is 0. V naught in the x direction is v naught cosine theta, and a in the x direction is 0. So x becomes v naught cosine theta times t. V in the x direction can be described with v naught xt plus at. Now a is 0 again, so v in the x direction is constant, so it's just v naught cosine theta. For the vertical component, we would use y equals y naught plus v naught yt plus 1/2 at squared. V naught y is v naught sine theta, and a is negative g, negative 9.8. Vy is described with v naught yt plus at. And again, v naught y is v naught sine theta, and then of course a is negative g. It is often helpful to have equations for flying time, horizontal range, and maximum height. Flying time, we will start with y equals y naught plus v naught yt plus 1/2 at squared. So both y and y naught are 0. So we have 0 equals v naught yt plus 1/2 at squared. Now v naught y is equal to v naught times sine of theta, and of course a is equal to negative g. So then we have 0 equals v naught sine theta t minus 1/2 gt squared. So v sine theta t equals 1/2 gt squared. Divide both sides by t. Now if we solve for t, we're going to multiply by 2 and divide by g. So we get t equals 2 v naught sine theta over g. And that is equal to the total time in the air. Horizontal range. So we will start with x equals x naught plus v naught x t plus 1/2 at squared. So x naught is 0, and acceleration in the x direction is also 0. So we have x equals v naught x t. Now v naught x is equal to v naught cosine theta, and t, that's the total time in the air, we found was equal to 2 v naught sine theta over g. So we'll plug those in, and we get x equals v naught cosine theta times 2 v naught sine theta over g. So let's simplify that a bit, and we'll make that v naught squared times 2 sine theta cosine theta all over g. Now this sine theta cosine theta, that is equal to sine of 2 theta. So our answer is v naught squared sine 2 theta over g, and that is the horizontal range. Maximum height. So again, we're going to start off with y equals y naught plus v naught yt plus 1/2 at squared. Now only y naught is 0 because we're looking for y as the maximum height, and now t is half of the total time. So that's going to be equal to v naught sine theta over g. That's half of what we found before. And y, or v naught in the y direction, is still going to be v naught sine theta. A is still going to be equal to negative g. So let's plug all those things in. So we get y equals v naught sine theta times v naught sine theta over g minus 1/2 g times v naught sine theta over g squared. So we'll simplify that a bit, and we get v naught squared sine squared theta over g minus v naught squared sine squared theta over 2g. So it's 1 of something minus 1/2, and so we get v naught squared sine squared theta over 2g. Now this is the maximum height.